Hello, in this lecture we will answer two questions. In the first question we'll find out the side length of square ABCD, and in the second question we'll find out the length of line segment AD that is equal to x. So we'll start with the first question. In the drawing we have square ABCD. We know that the short line segment DE equals to 1 unit. We also inside this square we have this circle, and we know that the radius of this circle is equal to 2 units, and we want to find out the length of one side of square ABCD. So first of all we will define the side length of square ABCD as x. That is to say, we here AB equals to x according to our definition. AE is also equals to x, AD equals to x. This equals to x. And BC also equals to x according to our definition. In the next step, I will present to you rule number 1 that I have already mentioned in the past. According to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. I repeat again, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. So we will define the center of this circle as O. We define the point of tendency of tangent AD in this circle as M. So here OM is the radius of this circle, so we'll define the radius of this circle as R, and we know that R equals to 2 units. So here the radius OM is the radius of this circle, and we know that the radius OM, it is drawn to the point of tendency. That is to say, it is drawn to point M, that is the point of tendency of tangent AD in this circle. And whenever we have a radius that is drawn to the point of tendency, then the tangent AD will be perpendicular to the radius MO. So AD is perpendicular to MO according to rule number 1. That is to say, this angle equals to 90 degrees, and this angle will be also equal to 90 degrees. Okay, we will define the point of tendency of tangent AB with this circle as L. We join points O and L together by a straight line. line segment OL is the radius of this circle. Therefore, it is equal to R, that is equal to 2 units. Why? Because it starts from the center of the circle and ends at point L, that is a point of the circle itself. And this is exactly the definition of a radius. So here we have the radius ON that is drawn to the point of tendency. That is to say, it is drawn to point M, that is the point of tendency of tangent AB with this circle. Whenever we have a radius that is drawn to the point of tendency, then the tangent AB will be perpendicular to the radius LO. So AB is perpendicular to LO, that is to say, this angle equals to 90 degrees, and this angle will be also equal to 90 degrees according to rule number 1, of course. And we know that all the angles inside a square are right angles, so angle DAB in square ABCD must be equal to 90 degrees. So actually in quadrilateral MOAL, this quadrilateral, we have 1, 2, 3 right angles. Okay? 1, 2, 3 right angles. So, and I write it down that in quadrilateral MOAL, we have 3 right angles. The sum of 3 right angles is 90 degrees times 3 is 270 degrees, plus the size of the fourth angle MON. In total, the sum of those 4 angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. So here we subtract 270 degrees from this equation, and we get that the missing angle MON, is equal to 360 degrees minus 270 degrees, it is equal to 90 degrees. So the missing angle, it is a right angle, it is equal to 90 degrees. So I can write here that this angle equals to 90 degrees. So actually in quadrilateral MOAL, we have 4 right angles, and any quadrilateral that has 4 right angles must be at least a rectangle. Okay, so I write it down. So we relate to quadrilateral MOAL as a rectangle. Okay, quadrilateral MOAL is a rectangle. And we know that the opposite sides of a rectangle are equal to each other. That is to say, the opposite sides of rectangle MOAL, they are equal to each other. That is to say, MO equals to AL. MO equals to AL. But we have already found out that MO equals to 2 units. It is the radius of the circle. So we can write here that MO equals to 2 units. And from this equation, 2 equals to MO equals to AL. we derive that AM is also equals to 2 units. So here, write here that AM equals to 2 units. Likewise, according to the rule that the opposite sides of a rational angle are equal to each other, we get that MA equals to OL. MA equals to OL. But here we've already found out that ON equals to 2 units. So we can write here that ON equals to 2 units. And from this equation, MA equals to ON equals to 2 units, we derive that MA is also equals to 2 units. MA equals to 2 units. So I can write it the following that MA equals to 2 units. So we actually found out that all the sides of quadrilateral MOAL they are equal to each other, they are equal to 2 units, therefore quadrilateral MOAL is not a rectangle but a square. Quadrilateral MOAL is a square. Okay, in the next step, I will present to you rule number 2 that I've already mentioned in the past. According to rule number 2, the lengths of two tangents from a common extreme point to a circle are equal. I repeat again, the lengths of two tangents from a common extreme point to a circle are equal. So here we will focus on the common extreme point, point E. From the common extreme point, point E, we have two tangents to the circle. Here we will define the point of tendency of line segment EB with this circle as point Z. So from point E we have two tangents to this circle. The first tangent is tangent EM. And the second tangent to this circle from point E is EZ. And according to rule number 2, the lengths of those two tangents must be equal to each other. That is to say, EM must be equal to EZ according to rule number 2 that I mentioned. What is the length of EM? For the drawing, it is very easy to see that the length of tangent EM it is equal to dA minus dE minus MA. I repeat again, EM equals to dA minus DE minus MA. So EM equals to dA equals to x according to our definition, minus dE equals to 1 unit according to what is given as the question, minus MA equals to 2 units according to what we have already found out, MA equals to 2 units. So in conclusion, we found out that EM equals to x minus 1 minus 2. So EM equals to x minus 1 minus 2 is x minus 3. EM equals to x minus 3. So we can write here that EM equals to x minus 3. Okay. But according to rule number 2, we have already found out that EM equals to EZ. EM equals to EZ according to rule number 2 from one side, but from the other side, we just right now found out that EM equals to x minus 3. So we can write here that EM is also equals to x minus 3. And from this equation, x minus 3 equals to EM equals to EZ, we will derive that EZ, it is also equals to x minus 3. EZ equals to x minus 3. So we can write here that EZ equals to x minus 3. In the next step, we will focus on the common external point, point B. From the common external point, point B, we have two tangents to this circle. The first tangent to this circle from the common external point, point B is tangent BL. And the second tangent to this circle from point B is tangent BZ. And according to rule number 2, the lengths of those two tangents are equal to each other. That is to say, tangent BL equals to tangent BZ according to rule number 2. And what is the length of tangent BL? The length of tangent BL from the drawings is very easy to see that the length of tangent BL, it is equal to BA minus LA. Again, BA minus LA equals to BL. BA minus LA. So BL equals to BA minus LA. So BL equals to here BA equals to x according to our definition, and LA equals to 2 units according to what we have already found out. So in conclusion, we found out that BL equals to x minus 2. So we can write here that BL equals to x minus 2. But we have already found out that BL equals to BZ. Can I tell that BL equals to BZ according to rule number 2 from one side, but from the other side, we just right now found out that BL equals to x minus 2. So we can write here that BL equals to x minus 2. And from this equation, x minus 2 equals to BL equals to BZ, we will derive that BZ it is also equals to x minus 2. BZ equals to x minus 2. Okay? So I can write here that BZ equals to x minus 2. What is the length of line segment EA? From the drawing, it is very easy to see that EA equals to DA minus DE. DA minus DE equals to EA. Okay? DA minus DE equals to EA. So EA equals to DA. DA equals to x according to our definition, minus DE. D equals to 1 unit according to what is given as the question. So in conclusion, I found out that EA equals to x minus 1. EA equals to x minus 1. In the next step, I will copy the right triangle EAB in this new page, and we will implement the Pythagoras theorem on this triangle EAB. We've already found out that EA equals to x minus 1. And according to our definition, AB equals to x. What is the length of the hypotenuse EB? The length of the hypotenuse EB is equal to x minus 3 plus x minus 2. Okay, this is the right triangle AB that I copied from the original drawing. The hypotenuse EB equals to x minus 3 plus x minus 2, so the hypotenuse EB equals to x plus x is 2x, minus 3 plus minus 2 is minus 5. So in conclusion, found out that the hypotenuse EB equals to 2x minus 5. Now we will implement the Pythagoras theorem on the right triangle EAB. So here, by PT, the information from Pythagoras theorem. So according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is EB, so the square of the hypotenuse is EB squared. And it must be equal to the sum of the squares of the perpendiculars, that is to say, it must be equal to EA squared plus AB squared. So according to the Thomas theorem, we get that EB squared equals to EA squared plus AB squared. EB equals to 2x minus 5, the hypotenuse EB equals to 2x minus 5, therefore the square of the hypotenuse is 2x minus 5 squared, that is equal to EA squared. EA equals to x minus 1, so EA squared equals to x minus 1 squared, plus AB squared. AB equals to x, so AB squared will be equal to x squared. We will open the brackets on both sides of this equation, equation number 1. Two x minus 5 we'll find out the value of 2x minus 5 squared according to the algebraic identity that a minus b squared equals to a squared plus b squared minus 2 times ab. So 2x minus 5 squared, it will be equal to 2x squared, that is 2x squared is 4x squared, plus 5 squared, that is 25, minus 2 times 2x is minus 4x, and minus 4x times 5 is minus 20x. And it is equal to x minus 1 squared. X minus 1 squared, it is equal to x squared plus 1 squared, that is 1, minus 2x plus x squared. So in this side of the equation we have 4x squared minus 20x plus 25. On the other side of equation number 1 we have x squared plus x squared is 2x squared minus 2x plus 1. So first of all we subtract 2x squared from this equation, equation number 1. So 2x squared minus 2x squared is 0, and 4x squared minus 2x squared is 2x squared. We have here minus 20x, and the other side of the equation number 1 we have minus 2x. So we will add 2x to this equation, equation number 1. 2x minus 2x is 0, and minus 20x plus 2x is minus 18x. So here we have, on this side of the equation number 1 we have 1, and the other side we have 25. So we will subtract 1 from this equation, equation number 1, and we will get that 1 minus 1 is 0, so 1 will get cancelled, and 25 minus 1 equals to 24. So actually in conclusion we found out that according to equation number 1, 2x squared minus 18x plus 24 equals to 0. Here we'll divide this equation, equation number 1 by 2. And we will get that according to equation number 1, two x squared over 2 is x squared, minus 18x over 2 is minus 9x, 24 over 2 is 12. and 0 over 2 is 0. So in conclusion, we found out that according to equation number 1, x squared minus 9x plus 2f equals to 0. So this is a quadratic equation. And the coefficient A in this quadratic equation is 1. The coefficient B is equals to minus 9. And the coefficient C equals to 12. And the general formula for solving out a quadratic equation is x equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. So we put the data inside this formula in order to find out the value of the values of x. So according to this formula, we get that x equals to minus b, b equals to minus 9, therefore minus b is minus 9, that is plus 9, plus minus square root of b squared. B equals to minus 9, so b squared is minus 9 squared, that is 81. Minus 4 times a is 1, times c is 12. Over 2a. A equals to 1, so 2 times 1 is 2. So here, x equals to 9 plus minus square root of 81 minus 4 times 12 is minus 48 over 2. So actually we found out that x equals to 9 plus minus square root of 81 minus 48 is 33, so inside the root we left only with 33 over 2. So here we will have two solutions that are possible for x. The first solution for x is that x equals to 9 minus square root of 33 over 2. 9 minus square root of 33 over 2 is 1.62. So according to the first solution, x equals to 1.62 units. So here the value of x, this is x, according to the first solution, it is equal to 1.62 units. But here we have already found out that AL itself, it is equal to 2 units, and from the drawing it is obvious that x is longer than AL, and because of the fact that x is longer than AL, and AL equals to 2, it means that x is greater than 2. Okay, from the drawing, it is obvious that x is greater than 2 units. Okay, from the drawing, you can see that x is greater than 2 units. But according to the first solution for x is equal to 1.62 units, that is less than 2 units. So according to the first solution, x is less than 2 units, but from the drawing, it is obvious that x is greater than 2 units. So this answer, the first answer to the question that x is equal to 1.62 is incorrect answer. We will cancel this solution and we'll focus on the second solution. The second solution to the question is, to the quadratic equation, is x equals to 9 plus square root of 33 over 2. 9 plus square root of 33 over 2 is 7.37 units. Okay? So we actually found out that one side of square ABCD, it is equal to either 9 plus square root of 33 over 2 units, or in terms of numbers, one side of square ABCD, it is equal to 7.37 units. So AB equals to BC equals to CD equals to DA equals to 7.37 units. We finished with the first question. In the next step, I present to you the second question, and we solve the second question in two different methods. In the drawing, we have here triangle ABC. We know that side AB equals to A units, side AC equals to 2A units, line segment BD equals to 2 units, angle BAD equals to 60 degrees, angle DAC equals also to 60 degrees, and we want to find out the length of line segment AD that is equal to x. So first of all, I will present to you the angle bisector theorem. So I already mentioned it in the past, so I will do it quickly. The angle bisector theorem is true in any triangle. So actually, if we have triangle ABC that could be any triangle, this is triangle ABC, and we also, in triangle ABC, we have the angle bisector AD. So why AD is angle bisector? Because of the fact that it divides angle BAC, this angle, into two halves. Each half equals to theta. Therefore, AD is the angle bisector. So I write here that AD is angle bisector. So only and only if we have angle bisector in triangle ABC, we can implement the angle bisector theorem. And according to angle bisector theorem, the following equation is true: that AB over AC equals to BD over DC. I repeat again. Only and only if you have angle bisector theorem in triangle ABC, you can implement the angle bisector theorem. And according to angle bisector theorem, we will get that AB over AC equals to BD over DC. So we actually can implement the angle theorem in triangle ABC. Why? Because in triangle ABC we have line segment AD that is angle bisector. Why line segment AD is angle bisector? Because of the fact that it divides angle BAC, this angle BAC into two halves. Each half equals to 60 degrees. So angle BAC equals to 180 degrees, 120 degrees. And the angle bisector AD divides angle BAC into two halves. Each half equals to 60 degrees. So because of the fact that in triangle ABC we have the angle bisector AD, we can implement the angle bisector theorem in triangle ABC. Okay? So in triangle ABC, according to the angle bisector theorem, we'll get that AB over AC equals to BD over DC. Okay? Here, AB equals to A units according to what is given as the question. AC equals to 2 units according to what is given as the question. BD equals to 2 units according to what is given as the question. And this is the missing line segment, so we leave it as it is. So actually, according to equation number 1, we found out that A over 2A equals to 2 over DC. We have A in the numerator and A in the denominator, so A will get cancelled on this side of equation number 1. And we left only with 1/2 that is equal to 2 over DC. So 1/2 equals to 2 over DC. Here we will cross multiply this equation number 1, and we will get that according to equation number 1, DC equals to 2 times 2. So that is to say, DC equals to 2 times 2, 2 times 2 is 4. So we found out that DC equals to 4 units. Here we can write down that DC equals to 4 units. In the next step we will do a construction. We will extend side CA of triangle ABC by a straight line. So we extended side CA by a straight line, and then from point B we will raise perpendicular to the extended CA. From point B we will raise the perpendicular to the extended CA. So actually this angle equals to 90 degrees according to our construction. This angle equals to 90 degrees according to our construction. We will define the touching point of the extended CA and the perpendicular from point B as E. So here I will repeat again that angle BEA equals to 90 degrees according to our construction. Angle BEA it is equal to 90 degrees according to our construction. So CA or AC is one side of triangle ABC. So CA is a side of a triangle, it is absolutely a straight line. Okay, CA is a straight line. And then we extended the straight line CA by straight line and we got line segment EC. When you extend a straight line by straight line, the result must be a straight line. Therefore, the result of the extension of the straight line CA by straight line is EC. Therefore, EC is a straight line. So we can write here that EC is a straight line because when you extend a straight line by straight line, the result must be a straight line. So we know that EC is a straight line, and we have the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. Okay, the sum of the angles on one side of a straight line is equal to 180 degrees. Okay, so if we focus on the lower side of the straight line EC at point A, repeat again, if we focus on the lower side of the straight line EC at point A, then the sum of the angles here must be equal to 180 degrees. So which angles do we have at the lower side of EC at point A? We have here 60 degrees. This angle equals to 60 degrees plus another angle that is equal to 60 degrees plus angle EAB. So the sum of those three angles must be equal to 180 degrees according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. Okay, so here 60 degrees plus 60 degrees is 120 degrees plus angle EAB in total. The sum of those three angles must be equal to 180 degrees. Here we subtract 120 degrees from this equation and we get that the missing angle EAB, it is equal to 180 degrees minus 120 degrees, it is equal to 60 degrees. So here angle EAB equals to 60 degrees. Okay. In the next step, we'll focus on the right green triangle EAB. On the right green triangle EAB, we know that cosine 60 degrees, cosine 60 degrees equals to EA over BA. I repeat again, on the right given triangle, triangle EAB, cosine 60 degrees equals to EA over BA. So it is equal to EA over BA. But BA equals to A units according to what is given as the question, so we substitute BA by A, and cosine 60 degrees equals to 1 half, so we substitute cosine 60 degrees by 1 half, so 1 half equals to EA over A. We'll multiply this equation by A, and we'll get that EA equals to A over 2. EA equals to A over 2. So actually, you can write here that EA equals to A over 2 units. We will continue to focus on the right green triangle, triangle EAB. In the right green triangle, triangle EAB, sinus 60 degrees, sinus 60 degrees equals to EB over BA. EB over BA. I'll repeat again. On the right triangle EB, sinus 60 degrees equals to EB over BA. So sinus 60 degrees equals to EB over BA, but BA equals to A, so we substitute BA by A. So we found out that sinus 60 degrees equals to EB over A. Sinus 60 degrees equals to square root of 3 over 2, so we substitute sinus 60 degrees by square root of 3 over 2. So square root of 3 over 2 equals to EB over A. Here we multiply this equation by A, and we'll get that EB equals to square root of 3 over 2 times A. So EB equals to square root of 3 over 2 times A. So we can write here that EB equals to square root of 3 over 2 times A. In the next step, we will implement the Pythagoras theorem on the right big triangle, triangle EBC. So I copy the right big triangle, triangle EBC in the new page, and we will implement the Pythagoras theorem on the big triangle, triangle EBC. Okay. What is the length of EC? The length of side EC? From the drawing, it is very easy to see that EC equals to 2A plus A over 2. EC equals to 2A plus A over 2. 2a plus a over 2 is 2.5a. And 2.5a is 5 over 2a. So here we found out that EC equals to 5 over 2 times a. We have already found out that EB equals to square root of 3 over 2 times a. And the hypotenuse BC equals to 2 plus 4, that is 6. So this is actually the right triangle ABC that is a copy from the original drawing. So we will implement the Pythagoras theorem in the right triangle ABC. So here, by PT is the relation for Pythagoras theorem. And according to the Pythagoras theorem, we get that this will be equation number 2. The square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is BC. Therefore, the square of the hypotenuse is BC squared. And it must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to EB squared plus EC squared. Okay, so according to the Pythagoras theorem, we found out that BC squared equals to EB squared plus EC squared. So BC equals to 6 units, therefore BC squared will be equal to 6 squared, that is 36. And it is equal to EB squared. EB equals to square root of 3 over 2 times A, of course. Therefore, EB squared will be equal to square root of 3 over 2 times A squared plus EC squared. EC equals to 5 halves times A. Therefore, EC squared will be equal to 5 halves times A squared. So here we will open the brackets on this side of equation number 2, and we will get that according to equation number 2, 36 equals to square root of 3 over 2 squared is 3 quarters A squared plus 5 halves A squared is 25 quarters A squared. So according to equation number 2, we found out that 36 equals to 3 quarters plus 25 quarters is 28 quarters times A squared, and 28 over 4 is 7. So we found out that according to equation number 2, 36 equals to 7A squared. Here we divide this equation number 2 by 7, and we get that according to equation number 2, A squared equals to 36 over 7. So here we take a root out of this equation number 2, and we get that A equals to square root of 36 is 6 over square root of 7. So we found out that A equals to 6 over square root of 7 units. In the next step, I will present to you a new rule that will be rule number 3. According to rule number 3, if we have triangle ABC that could be any triangle, and this is triangle ABC, and in triangle ABC we have 9 segment AD that is actually defined as angle bisector. AD is angle bisector. Why AD is angle bisector? Because of the fact that it divides angle BAC into 2 halves. Each half equals to theta. So if we have a triangle ABC that could be any triangle, the angle bisector AD, then the following equation is true, that AD squared equals to AB times AC minus BD times DC. I repeat again. If a triangle ABC that could be any triangle, we have the angle bisector AD, then the following equation is true, that AD squared, that is actually the angle bisector squared, it is equal to AB times AC minus BD times DC. Again, AD squared equals to AB times AC minus BD times DC. So we actually can implement rule number 3 in triangle ABC. Why we can implement rule number 3 in triangle ABC? Because of the fact that in triangle ABC we have the angle bisector AD. So I'll copy the right triangle, I'll copy triangle ABC in this new page, and we will implement the angle bisector rule number 3 in triangle ABC. I repeat again that here we can implement rule number 3 in triangle ABC only because of the fact that triangle ABC has the angle bisector AD. Otherwise, you cannot implement rule number 3 in any triangle that has no angle bisector in it. Okay, so here AD is the angle bisector. So this is triangle ABC, this is a copy from the original drawing. According to rule number 3, we get that here AD equals to X according to what is given as the question. According to rule number 3, we get that AD squared equals to AB times AC minus BD times DC. I repeat again, in triangle ABC we have the angle bisector AD. AD is the angle bisector because it bisects angle BAC into two halves. Each half equals to 60 degrees. So according to rule number 3, we'll get that AD squared equals to AB times AC minus BD times DC. AD equals to X, so AD squared is X squared. That is equal to AB is A times AC is 2A, according to what is given in the question, minus BD. BD is 2 times DC is 4. So in conclusion, found out that according to equation number 3, X squared equals to A times 2A is 2A squared minus 2 times 4 is 8, so it is minus 8. So here, according to equation number 3, we get that X squared equals to 2A squared. 2 times A squared, but A squared equals to 36 over 7, so we substitute A squared by 36 over 7 minus 8. So according to equation number 3, we found out that X squared equals to 2 times 36 is 72 over 7. Here we will multiply minus 8 by 7 and then we will divide it by 7 in order to have a common factor with this expression. So minus 8 times 7 is minus 56. So in conclusion, we found out that X squared equals to 72 minus 56. 72 minus 56 is 16 over 7. So X squared equals to 16 over 7, according to equation number 3. Here we take a root out of this equation, equation number 3, and we get that X equals to square root of 16 is 4 over square root of 7. So in conclusion, we found out that X, that is also equals to line segment AD, it is equal to either 4 over square root of 7 units, so in terms of numbers, it is equal to 1.51 units. Okay, that is the answer to the question. So I write here also that X equals to either 4 over square root of 7 units, so in terms of numbers, it is equal to 1.51 units. Okay, so we finish with the first method. In the next step, I will present to you how to find out the length of line segment AD that is equal to X according to the second method. In the second method, we define angle ADB as theta. If angle ADB equals to theta, then angle ADC must be equal to 180 degrees minus theta, because it is complementary to 180 degrees. BC is a side of a triangle, therefore it is a straight line. And we know we have the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So the sum of the angles on the upper side of the straight line BC it is equal to 180 degrees. So if this angle ADB equals to theta, then angle ADC must be equal to 180 degrees minus theta. So in the next step, I will present to you the law of sines, and we will implement the law of sines in triangles ABD and triangle ADC. So what is the law of sines? the law of sines is true in any triangle. So if you have triangle ABC that could be any triangle, this is triangle ABC. Side BC of triangle ABC equals to A units in its length. Side AC of triangle ABC equals to B units in its length. And side AB of triangle ABC equals to C units in its length. Then, according to the law of sines, we get that A over sine A equals to B over sine B equals to C over sine C. I repeat again, the triangle ABC, this could be any triangle. A over sine A equals to B over sine B equals to C over sine C. Capital A is the size of angle BAC, this angle. Capital B is the size of angle ABC, this angle. And capital C is the size of angle ACB, this angle. Okay, the length of side BC equals to A units, the length of side AB equals to B units, and the length of side AB of triangle ABC equals to C units. Okay, so we'll implement the law of sines in triangle ABD, this triangle. So actually, in triangle ABD, according to the law of sines, we'll get that A over sinus theta equals to 2 over sinus 60 degrees. I repeat again, in triangle ABD, this triangle, A over sinus theta equals to 2 over sinus 60 degrees according to the law of sines. In the next step, we will implement the law of sines in triangle ADC, this triangle. So in triangle ADC, according to the law of sines, we will get that 2A over sinus 180 degrees minus theta equals to DC over sinus 60 degrees. I'll repeat again. in this triangle ABC, according to the law of sines, we will get that 2a over sinus 180 degrees minus theta equals to DC over sinus 60 degrees. We have the trigonometric identity that sinus 180 degrees minus theta equals to sinus theta. So actually we can substitute sinus 180 degrees in this equation number 2 by sinus theta. We'll do it now and we get that according to equation number 2, a over sinus theta equals to DC over sinus 60 degrees. Okay, so actually according to equation number 2, 2 times a over sinus theta, but a over sinus theta, it is equal to 2 over sinus 60 degrees according to equation number 1. So we can substitute a over sinus theta in this equation number 2, by 2 over sinus 60 degrees from equation number 1. So it is 2 over sinus 60 degrees. We substituted a over sinus theta by 2 over sinus 60 degrees from equation number 1, and it is equal to DC over sinus 60 degrees. So we have here sinus 60 degrees on both sides of the equation, so sinus 60 degrees will get cancelled. What is left from equation number 2 after we cancelled sinus 60 degrees? What is left is actually here, according to equation number 2, DC equals to 2 times 2, that is to say DC equals to 2 times 2 is 4, so this equals to 4 units. Here we can write down that DC equals to 4 units, exactly as we have already found out in the first method. In the next step, we will implement the law of cosines in triangle ABC, so I present to you the law of cosines that I already presented to you in the past. So here we have the law of cosines. The law of cosines is true in any triangle. So here if we have triangle ABC that could be any triangle, this is triangle ABC. The angle between side AB and side AC is theta. The length of side AB of triangle ABC is equal to A units. Side AC equals to B units in its length, and side BC equals to C units in its length. Then, according to the law of cosines, we will get that cosine theta equals to A squared plus B squared minus C squared over 2 times A times B. Again, triangle here we have triangle ABC that could be any triangle. You know that the length of side AB is A units, the length of side AC is B units, and the length of side BC is C units, and the angle between side AB and side AC is theta. Then, according to the law of cosines, we get that cosine theta equals to a squared plus b squared minus c squared over 2 times ab. So I already said that we'll implement the law of cosines in triangle ABC. So I'll copy triangle ABC in this new page, and we'll implement the law of cosines in triangle ABC. This is triangle ABC. There's a copy from the original drawing. BC equals to 2 plus 4, that is 6. Angle BAC, this angle equals to 60 degrees plus 60 degrees is 120 degrees. So this is triangle ABC, that the copy from the original drawing. According to the law of cosines, we get that cosine (120 degrees) equals to here AB squared is A squared plus AC squared is 2A squared, that is 4A squared, minus BC squared. BC equals to 6, so BC squared is 36, so it is minus 36 over 2 times A times 2A. Cosine 120 degrees equals to minus 1/2. So we substitute cosine 120 degrees by minus 1/2. And it is equal to a squared plus 5 plus 4a squared equals to 5a squared minus 36 over 2a times 2a. So here we have 2 on both sides of the equation, so 2 will get cancelled. In the next step, we will multiply equation number 3 by 2a squared, and we get that 2a squared times minus 1 is minus 2a squared. That is equal to 5a squared minus 36. Here we will add 2a squared and also 36 simultaneously to this equation number 3, and we get that according to equation number 3, 5a squared plus 2a squared is 7a squared. That is equal to 36. So here we divide this equation number 3 by 7, and we get that according to equation number 3, a squared equals to 36 over 7. Here we take out of this equation number 3, and we get that a equals to square root of 36 is 6 over square root of 7. So if I know that a equals to 6 over square root of 7, in the next step I present to you a new formula to find out the area of any triangle. So here if we have triangle ABC, that could be any triangle, This is triangle ABC. That could be any triangle. And we know that side AB of triangle ABC equals to A units in its length, side AC equals to B units in its length, and the angle between side AB and side AC is theta. Then according to the new formula to find out the area of any triangle, we get that the area of triangle ABC, the area of triangle ABC, it is equal to A times B times sinus theta over 2. Okay? The area of this triangle ABC, that could be any triangle, will be equal to A times B times sinus theta over 2. Side AB equals to units in its length, side AC equals to B units in its length. So the area of this triangle ABC equals to A times B times sinus theta over 2. We will use the new formula to find out the area of any triangle in our drawing. Here we have, it is very easy to see that from the drawing that the area of triangle ABC, the big triangle ABC equals to the area of triangle ABD plus the area of triangle ADC. I repeat again, the area of the big triangle ABC equals to the area of triangle ABD plus the area of triangle ADC. So write it down. The area of the big triangle ABC, it is equal to the area of the small triangle ABD plus the area of the small triangle ADC. Okay? I repeat again. The area of the big triangle ABC equals to the area of the small triangle ABD plus the area of the small triangle ADC. So what is the area of triangle ABC? We'll calculate the area of triangle ABC according to the new formula. The area of triangle ABC according to the new formula will be A times 2A times sinus 60 degrees plus 60 degrees is 120 degrees, so it is times sinus 120 degrees over 2. I'll repeat again, the area of triangle ABC according to the formula, it will be equal to A times 2A times sinus 180 degrees over 2. And it is equal to the area of the small triangle ABD. The area of the small triangle ABD equals to, according to the formula, it will be equal to A times X times sinus 60 degrees over 2. I'll repeat again, the area of this triangle ABD according to the formula will be equal to A times X times sinus 60 degrees over 2 plus the area of triangle ADC. The area of triangle ADC, this triangle according to the formula, will be equal to X times 2A times sinus 60 degrees over 2. I'll repeat again, the area of this triangle ADC according to the new formula will be equal to X times 2A times sinus 60 degrees over 2. So actually, in this equation we have 2 on both sides of the equation, so 2 will get cancelled. We have A on both sides of the equation, so A will also get cancelled. And we know that sinus 120 degrees equals to sinus 60 degrees, therefore sinus 60 degrees will also get cancelled. So what is left from this equation after we cancel all the variables here. What is left is actually in this side of the equation we left only with 2a. On the other side of the equation we have here x plus 2x. So in conclusion found out that 2a equals to x plus 2x. That is to say 2a equals to x plus 2x is 3x. Here we divide this equation by 3 and we get that x equals to 2 over 3 times a. Okay? But we have already found out that a equals to 6 over square root of 7 units. Here a equals to 6 over square root of 7 units, so we substitute a by 6 over square root of 7 units, and we get here that 2 times 6 is 12 over 3 times square root of 7. 2 over 3 is 4, 12 over 3 is 4, here 12 over 3 is 4, over square root of 7 units. So in conclusion we found out that x equals to 4 over square root of 7 units. In terms of numbers it is equal to 1.51 units. So we can write down here that x equals to either 4 over square root of 7 units, or in terms of numbers it is equal to 1.51 units. We finish with the second method. In the next step I will summarize the lecture. We start with the first question. So here we have square ABCD. We know that line segment D equals to 1 unit. Inside this square we have this circle, and the radius of this circle is 2 units. It's equal to 2 units. And we want to find out the side length of square ABCD. So first of all we define the side length of square ABCD as x, that is to say DA equals to CB equals to AB equals to AD equals to x according to our definition. Then I presented to you rule number 1. According to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. So here we have the radius OM that is drawn to the point of tendency, that is to say it is drawn to point M, that is the point of tendency of tangent AD with this circle. And whenever you have a radius that is drawn to the point of tendency, then the tangent AD will be perpendicular to the radius MO. So AD is perpendicular to MO, that is to say this circle equals to 90 degrees and this circle will also equal to 90 degrees. In the next step, we join points O and M together by straight line. OM is the radius of this circle. Why? Because it starts from the center of the circle and ends at point M, that is the point on the circle itself. This is exactly the definition of a radius. So OM equals to R, that is equal to 2 units, that is the radius of the circle. So here we have the radius OM that is drawn to the point of tendency, that is to say the radius OM is drawn to point N. That is the point of tendency of tangent AB with this circle. And whenever we have a radius that is drawn to the point of tendency, then the tangent AB will be perpendicular to the radius NO. So AB is perpendicular to NO, that is to say this circle equals to 90 degrees and this circle will be also equal to 90 degrees. And we know that all the angles inside the square are right angles, therefore this angle BAD That is one angle of square ABCD must be equal to 90 degrees. So actually in quadrilateral MOAL we have 1, 2, 3 right angles. Okay? In quadrilateral MOAL we have 3 right angles. The sum of 3 right angles is 90 times 3 is 270 degrees. Plus the size of the fourth angle that is actually angle MOL. In total, the sum of those 4 angles must be equal to 360 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Here we subtract the 270 degrees from this equation and found out that angle MOL equals to 360 degrees minus 270 degrees, it is equal to 90 degrees. So actually we found out that in quadrilateral MOAL we have 4 right angles. Any quadrilateral that those 4 right angles must be at least a rectangle. So we relate to quadrilateral MOAL as a rectangle. So in rectangle MOAL we know that MO must be equal to AL according to the rule that the opposite sides of a rectangle are equal to each other. Therefore MO must be equal to AL. MO equals to AL, but we have already found out that MO equals to 2 units. So we can write here that MO equals to 2 units, and from this equation U equals to MO equals to AL, we'll derive that AL is also equals to 2 units. Here AL is also equals to 2 units. Likewise, according to the rule that the opposite sides of a rectangle are equal to each other, we get that MA equals to OL. MA equals to OL. But we have already found out that ON equals to 2 units. So we can write here that ON equals to 2 units, and from this equation MA equals to ON equals to 2, we derive that MA is also equals to 2 units. Here MA is also equals to 2 units. So actually in quadrilateral MOAL we have 4 equal sides. All of its sides are equal to 2 units. Therefore quadrilateral MOAL is not a rectangle but a square. Quadrilateral MOAL is a square. In the next step, I presented to you rule number 2. According to rule number 2, the lengths of 2 tangents from a common external point to a circle are equal. I repeat again, the lengths of 2 tangents from a common external point to a circle are equal. So if we focus on the common external point E, from point E we have 2 tangents to this circle, tangent EM and tangent EZ. And according to rule number 2, they are equal to each other. That is to say, EM equals to EZ according to rule number 2. What is the length of EM? It is very easy to see that the length of tangent EM, it is equal to DA minus DE minus MA. EM equals to DA minus DE minus MA. So EM equals to DA. DA equals to X according to our definition. DE equals to 1 unit according to what is given as the question. And MA equals to 2 units according to what we have already found out. So in conclusion, we found out that EM equals to X minus 1 minus 2. X minus 1 minus 2 is X minus 3. So we found out that EM equals to X minus 3. So we can write here that EM, the tangent EM equals to X minus 3. But according to rule number 2, we have already found out that EM equals to EZ from one side, and from the other side, we just right now found out that EM it is also equals to X minus 3. So we can write here that EM equals to X minus 3, and from this equation X minus 3 equals to EM equals to EZ, we derive that EZ is also equals to X minus 3. EZ equals to X minus 3. EZ equals to X minus 3. Then we focused on the common external point B. Point B is the common external point. From the common external point B, we have 2 tangents to the circle, tangent BL and tangent BZ, and according to rule number 2, they are equal to each other. That is to say, BL equals to BZ according to rule number 2. What is the length of BL? From the drawing, it is very easy to see that the length of tangent BL equals to BA minus LA. Okay, BL equals to BA minus LA. BA equals to X according to our definition, LA equals to 2 units according to what you have already found out. So in conclusion, we found out that BL equals to X minus 2. So from one side we found out that BL equals to BZ according to rule number 2. We just right now found out that BL equals to x minus 2. So from this equation x minus 2 equals to BL equals to BZ, we derive that BZ is also equals to x minus 2. BZ is also equals to x minus 2. Then we found out the length of 9 segment EA. From the drawing it is very easy to see that the length of 9 segment EA is equal to DA minus DE. EA equals to DA minus DE. DA equals to x according to our definition. D equals to 1 unit according to what is given as the question. So in conclusion, we found out that EA equals to x minus 1. Then I copied the right triangle EAB in this new page and we implemented the Pythagoras theorem on this triangle EAB, the right triangle EAB. We just right now found out that EA equals to x minus 1, AB equals to x according to our definition, and the hypotenuse EB, the hypotenuse EB equals to x minus 3 plus x minus 2. Here, EB equals to x minus 3 plus x minus 3, x minus 3 plus x minus 2. X plus x is 2x, and minus 3 plus minus 2 is minus 5. So in conclusion, we found out that the hypotenuse EB equals to 2x minus 5. Then we implemented the Pythagoras theorem on the right big triangle EAB. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So that is to say, EB square equals to EA square plus AB square. EB equals to 2x minus 5, so AB square is 2x minus 5 square. It is equal to EA square. EA equals to x minus 1, so EA square is x minus 1 square. Plus AB square. AB equals to x, so AB square is x square. We open the brackets on both sides of the equation. 2x minus 5 square equals to 2x squared, that is 4x squared, plus 5 squared, that is 25, minus 2 times 2x is minus 4x, times 5 is minus 20x. That is equal to x minus 1 squared. X minus 1 squared equals to x squared plus 1 minus 2x plus x squared. So in this side of equation number 1, we have 4x squared minus 20x plus 25, that is equal to x squared. X squared plus x squared is 2x squared minus 2x plus 1. We subtracted 2x squared from equation number 1. So 2x squared minus 2x squared is 0. And here 4x squared minus 2x squared is 2x squared. Then we have minus 20x and also minus x minus 2x, so we added 2x to this equation. 2x minus 2x is 0, and minus 20x plus 2x is minus 18x. We have 1 on this side of the equation and 25 on the other side of the equation, so we subtracted 1 from equation number 1, and we got that 1 minus 1 is 0, and 25 minus 1 is 24. So in conclusion, we got the quadratic equation, 2x squared minus 18x plus 24 equals to 0. So we got the quadratic equation that 2x squared minus 18x plus 24 equals to 0. We divided this quadratic equation by 2. So 2x squared over 2 is x squared, minus 18x over 2 is minus 9x, and 24 over 2 is 12, and 0 over 2 is 0. So let's write out the quadratic equation that x squared minus 9x plus 12 equals to 0. In this quadratic equation, the coefficient a equals to 1, the coefficient b equals to minus 9, and the coefficient c equals to 12. And the general formula for solving out a quadratic equation is x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. Okay? And in our specific quadratic equation, we have x that is equal to 9, x equals to minus b equals to minus 9, so minus b is minus 9, that is plus 9, plus minus b squared, b equals to minus 9, so b squared is minus 9 squared, that is 81, minus 4 times a is 1, times c is 12. Over 2a, a is 1, so 2 times 1 is 2. So found out that x equals to 9 plus minus square root of 81 plus minus 4 times 12 is minus 48 over 2. So x equals to 9 plus minus 81 minus 48 is 33 over 2. So inside the root we left only 33. So here we will have two solutions that are possible for x. The first solution for x is x equals to 9 minus square root of 33 over 2. That is 1.62 units. So according to the first solution for x equals to 1.62 units. So here x equals to AB, it is one side of square ABCD, and one side of square ABCD that is equal to x, it is 1.62 units. Okay, but here AL that is shorter than x equals to 2 units. Here AL equals to 2 units, and x is longer than AL. That is to say, x that is longer than AL must be greater than 2 units. So here x must be greater than 2 units. X must be greater than 2 units. From the drawing you can see it easily that x must be greater than 2 units. But we found out that x equals to 1.62, that is less than 2 units. Okay, therefore this solution is the incorrect solution. We cancel this solution and focus on the second solution, that x equals to 9 plus square root of 33 over 2 units, so in terms of numbers it is equal to 7.37 units. So here one side of square ABCD, it is equal to 7.37 units, so we can present it also as 9 plus square root of 33 over 2 units. Okay, we finished with the first question. In the next step I will present to you how we solve the second question in two different methods. We'll start with the first method. In the first method, we have triangle ABC. We know that line segment BD equals to 2 units, line segment, side AB equals to A units, side AC equals to 2 units. Angle BAD, this angle equals to 60 degrees, angle DAC, this angle equals also to 60 degrees, and we want to find out the length of side AD that is equal to x. So first of all, I presented to you the angle bisector theorem that is through an any triangle. So triangle ABC could be any triangle. And we have AD is the angle bisector. Why AD is angle bisector? Because of the fact that it divides angle BAC into two halves. Each half equals to theta. So we can implement the angle bisector theorem in this triangle because of the fact that triangle ABC has the angle bisector AD. According to angle bisector theorem, we get that AB over AC equals to BD over DC. Again, AB over AC equals to BD over DC. We implemented the angle bisector theorem in triangle ABC. We can implement the angle bisector theorem in triangle ABC because of the fact that it has AD, and AD is defined as angle bisector. Why? Because it divides angle BAC into two halves. Each half equals to 60 degrees. Therefore, we can implement the angle bisector theorem in triangle ABC. And according to angle bisector theorem that we will implement in triangle ABC, we get that AB over AC equals to BD over DC. AB over AC equals to BD over DC. AB equals to A, AC equals to 2A, BD equals to 2, and this is the missing line segment. Here we have A in the numerator and A also in the denominator, so A will get cancelled, and we left only with one half that is equal to 2 over DC. Here we cross multiply this equation number 1, and we got that this equals to 2 times 2. That is to say this equals to 2 times 2, that is 4. So here this equals to 4 units. This equals to 4 units. Then we made the construction. We extended side CA by straight line, and from point B we raised perpendicular to the extended CA. So this angle equals to 90 degrees according to our definition. So here we have CA is a straight line. We extended the straight line CA by straight line, therefore CE is a straight line. C is a straight line. So we know that the sum of the angles from one side of a straight line is equal to 180 degrees. So if we focus on the lower side of the straight line EC at point A, then the sum of the angles here must be equal to 180 degrees. So which angles we have here? We have 60 degrees plus 60 degrees plus angle EAB. In total, the sum of those three angles must be equal to 180 degrees according to the rule that I mentioned. 60 degrees plus 60 degrees plus angle BAE must be equal to 180 degrees. 60 degrees plus 60 degrees is 120 degrees, plus angle EAB equals to 180 degrees. We subtracted 120 degrees from this equation and found out that the missing angle EAB equals to 60 degrees. So this angle equals to 60 degrees. Then we focus on the right triangle EAB. On the right triangle EAB, cosine 60 degrees equals to A over 2, and sine 60 degrees equals to square root of 3 over 2 times A. Then we implemented the Pythagoras theorem on the right triangle EBC, and according to the Pythagoras theorem, we get that EB square, BC square equals to EB square plus EC square. BC square equals to EB square plus EC square. BC equals to 6, so BC square is 36. EB equals to square root of 3 over 2 times A. So EB square is square root of 3 over 2 times A square. C equals to 5 halves times A, so C square is 5 halves times A square. We solved this equation and found out that A equals to 6 over square root of 7 units. Then I presented to you rule number 3. According to rule number 3, if we have triangle ABC that could be any triangle, and we have the angle bisector AD, then AD square equals to AB times AC minus BD times DC. We implemented rule number 3 in triangle ABC. This is triangle ABC that I copied from the original drawing. according to rule number 3, we get that AD squared equals to AB times AC minus BD times DC. AD equals to X, so AD squared is X squared. It is equal to AB, that is A, AC is 2A, minus DB is 2, and BD is 2, and here DC is 4. So in conclusion, we found out that X squared equals to 2A squared minus 8, and we found out that X equals to either 4 over square root of 7 units, so in terms of numbers it is equal to 1.51 units. Okay, then I presented to you how to find out the length of line segment AD that is equal to X according to the second method. In the second method we define angle ADB as theta, therefore angle ADC equals to 180 degrees minus theta. Then I presented to you the law of cosines. In any triangle, A over sine A equals to B over sine B equals to C over sine C. We implemented the law of sines in triangle ABD and also in triangle ADC. And we actually found out that DC equals to 4 units. Then we implemented the law of cosines in triangle ABC. According to the law of cosines in triangle ABC, cosine 120 degrees equals to A squared plus 4A squared minus 46 over 2A times A. And we found out that A equals to 6 over square root of 7 units. Then I presented to you a new formula to find out the angle of any triangle. In this triangle ABC, the angle of this triangle ABC equals to A times B times sinus theta over 2. So the area of triangle ABC equals to the area of triangle ABD plus the area of triangle ADC. Here, the area of triangle ABC, according to the new formula, is A times 2A times sinus 180 degrees over 2. The area of triangle ABD is A times X times sinus 60 degrees over 2. And the area of triangle ADC is X times 2A times sinus 60 degrees over 2. 2 will get cancelled, A also will get cancelled, and sinus 120 degrees equals to sinus 60 degrees. So sinus 60 degrees also will get cancelled. And we got that 2A equals to X plus 2X. So 2A equals to 3X. And we found out that X equals to either 4 over square root of 7 units, or in terms of numbers it is equal to 1.51 units. Okay, so in both methods we found out that the value of X it is equal to either 4 over square root of 7 units, or in terms of numbers it is equal to 1.51 units. Okay, thank you very much.